So I knew I would get cut off at some point during this. So I have a couple more examples left to go. And then you should be pretty good to get started on your IXL stuff. And looking at our next sequence. So once again, maybe you are not sure what your common difference or your common ratio is. You don't know if it's arithmetic or geometric. If you have absolutely no idea, I always start with arithmetic. Okay? So with arithmetic, you take the second number minus the first number and see what you get. 30 minus 13 gives me 17. So then I check to see, well, so 13 plus 17 is 30. 30 plus 17 is 47. And 47 plus 17 is 64. So I have an arithmetic and I'm adding 17 each time. So AN equals AN minus 1 plus 17. Next one, let's go the route of go with me and pretend you don't know what it is. Maybe you do, maybe you don't. Maybe you know what type of a sequence, but you have no idea what the common difference or common ratio is. So let's start with, we don't know at all if it's arithmetic or geometric. So we're gonna start with pretending it's arithmetic. We're gonna go 64 minus 128. You always, if you think it's arithmetic, you take the second number minus the first number all the time. Get negative 64. So 128 minus 64 is 64. Then I check 64 minus 64 is not 32. So that doesn't work. So that lets me know it's not arithmetic. It's got to be geometric. So now I'm going to do that again with the same numbers, except this time I'm going to do 64 divided by 128. Because if I think it's geometric, I take the second number divided by the first number. I can go back to Desmos, and I can do 64 divided by 128. I get 0.5, which I know is 1/2. Which basically means you're dividing by 2. So let's continue. Dividing by 2 I know is 64. 64 divided by 2 is 32. 32 divided by 2 is 16. So we have a geometric sequence with 1/2 as your common ratio, which means I have AN equals 1/2 times AN minus 1. Okay. Go with me, and let's say we don't know what it is. Now, it should hopefully pop into your mind that this 6, negative 12, 24, negative 48, it should hopefully pop into your mind that this cannot be arithmetic, because there's no way to add the same number each time or subtract the same number each time and go positive, negative, positive, negative. So arithmetic is out the window. So I'm just going to start right away with geometric. I'm going to take my second number divided by my first number. Negative 12 divided by 6 is negative 2. So 6 times negative 2 is negative 12. Negative 12 times negative 22 is positive 24. 24 times negative 2 is negative 48. So I have a geometric, and my common ratio is negative 2, which means I have AN equals negative 2 AN minus 1. Okay. Last one. Got some fractions to work with. I'm going to show you a couple of things with this specific problem. So first, if you have fractions, you start with fractions and you end with whole numbers, or in reverse, maybe you started with whole numbers and end with fractions, it is most likely not arithmetic. Now, if you had fraction, whole number, fraction, whole number, fraction, whole number, then it might be, because maybe you're adding a half each time. So you have 1, and then you have, 1 1/2, and then you have 2, and then 2 1/2, and that would make a fraction, whole number, fraction, whole number. But if all your fractions are at one end and all your whole numbers are at the other, it is most likely not arithmetic. So let's just go the geometric route. Now, I'm going to show you first in this case, and in some cases, the easier route to go. and then I'm going to show you what would happen if you had to do the harder route. So the easier route is we usually say take the second one and then divide by the first one, but that means I'm going to have a fraction divided by a fraction. I'm going to have fractions all over the place and going to be a mess. So instead, I'm going to move down the line and I'm going to take my 12 divided by the 3. You can take any two consecutive numbers and do this division as long as you take the one farther down the line divided by the one before it. And 12 divided by 3, well, that's pretty simple. That's just 4. So now I need to go check to see do all the other ones work though. So I'm going to start with 3 over 16. And I'm going to times it by 4. I get 3 over 4, which was what I wanted. Now I'm going to do 3 over 4 times 4 and see if I get 3 times 4. And I get 3, and 3 times 4 is 12. So that is my common ratio. So my recursive formula is AN equals 4 AN minus 1. Now I'm going to show you of a case or how to do this if you had fractions for all of them. Let's say you didn't have these nice 3 and these nice 12, and you had to do fractions. You would do the same thing, but you just need to be careful with it. You would do your second number divided by your first number. So in Desmos, you want to use some parentheses. You're going to take your second number is 3 over 4, your first number is 3 over 16. So you're going to take your second number, put it in the set of parentheses, and then divided, and then another set of parentheses, your first number, which is 3 over 16. So that it looks like this, where you have your entire first number, 3 over 4, divided by your entire second number, 3 over 16, and see how we got 4, which is what we had before. Okay? That's how you can do those if every single number is a fraction and you can't get away from it. All right? Then here's still your answer for your recursive formula.